Okay, welcome back. We are doing, what are we doing? 7.4, Ready, Set, Go, number one. So this is a review, and it's asking us to basically write a new equation based on the given transformations and then sketch the function on the same graph as the parent function. If the parent function has asymptotes, make sure you sketch them in. So y equals x squared, it has a vertical shift, a horizontal shift, and a vertical stretch or shrink. So I always write my generic equation like this. So it goes y equals, and then parentheses, x parentheses squared. And then I fill in all these things. So this plus 8, this vertical shift 8 happens outside of your parentheses because it's happening to the y, not to the x. Vertical means up and down, and that's happening in the y direction. So we want it to affect the y. So that's why we're doing it outside those parentheses. Similarly, this left 8, which is in horizontal shift, goes right and left. So you should be taking that 3 and have it affect the x before you square it. Okay. So the only problem is in X land, it's always backwards. So you think left, you're like, oh, that means minus. But in X, we live in backwards land, so we actually put plus. So I'm going to say that again. So in horizontal land, we shift it. Oops, sorry, lots of things happening. In horizontal land, we shift it backwards of what you normally think, right? So this plus 3 actually means left 3. Last but not least, we're going to vertically stretch or shrink this 1/4. So we're going to take this number here and we're going to put it as a multiplier. Some of you guys will remember this guy is now called our amplitude for sine and cosine, but he's basically our multiplier. Okay. And he basically takes my graph and either stretches it vertically, or I don't think about shrinking, I think about squishing. Squishing it. So this one's going to be a squish because it's 1/4. Okay. So normally, and this is what I like to do, I like to take my graph and I will be using this, I don't know, pink highlighted color here. I'm going to take it and I'm going to move it based on this, right? So I am going to go here. It's not what I wanted to do. Let's try again. Go here. Go slower, Miss Johnson. Okay. So I'm going to take this thing and I'm going to do what it says. Shift it up 8. So I'm going to pay attention to my vertex. Okay. So my vertex is going to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. So now my vertex is at 8. It's kind of fat, but just know that he's at 0, 8 now. And then I'm going to move him left 3. So 1, 2, 3. So now my vertex is at 8. Oh, no, don't do that. Sorry, we moved him. Now he's here at 8, negative 3, 8. And then we have to shrink him. Okay, so shrinking him means this. Like, can I do this? Yeah, it's like this. You made him like wider. Okay, so I'm just going to show you using a couple points. This point here went up 8, left 3. Oops, I should definitely use a darker color here. Okay, there's your vertex. Now before, if you look at this point was at 1, 1. And now if you look at negative 2, he's probably at negative 2, 1/4. Okay, so negative 2, 1/4. Or if you want to think about another point, I don't have any other good points. So this point at 1, 1 is now here at negative 2, 1/4. And I can't draw that accurately enough, but just know that he got squished down. Okay. So when you're doing these, all you have to remember is vertical shifts. These vertical shifts happen outside of your function or after your function. Think PEMDAS. It happens after that squared. Okay. As opposed to your horizontal shifts always happen within or inside 2x. And you have to remember lives in backwards land. And your vertical stretch is just going to be either going to make it wider if it's a compression, a squishing, or as stretching. Okay. Thanks for listening.